Good day everyone, my name is Mr. Ademujimi Adedotun. This class is brought to you by Isaac Humanitarian Foundation. We will be looking at magnification of spherical mirror. Magnification of spherical mirror. What is magnification? They call it lateral magnification or linear magnification. Lateral magnification or linear magnification, which has symbol of what? Of M. M. So by definition, so we can say what? Magnification equals to what? Equals to the height of image to the what? The height of what? The object. Height of object. Height of image to what? To height of object. So we can say M equals to HI upon HO. HI upon HO by definition. So that is the definition of magnification. Magnification or lateral magnification or linear magnification, which can be defined as the height of what? Of image to what? To the height of the object, that is HI over what? Over HO. So from there we can prove that M is equals to HI over HO, which is equals to minus V over U. Okay? Minus V over U. Note this. This is minus. Okay? Minus V over U. Minus V over U. That is magnification equals to HI over HO equals to minus V over what? Over U. Where V is what? The image distance. The image distance. Image distance. And U is what we call what? The object distance. Object distance. That's the distance of the object and distance of what? The image. Okay? So let's prove this. I would like to prove this. Why? Because there are some textbooks that they use what? V over what? Over U. Okay? But what I'm using is minus V over what? Over U. Magnification of spherical mirror. Proof. Let's look at the proof. So we know we are talking about a spherical mirror. Spherical mirror. So we have this. We have the principal axis. The principal axis. The principal axis. This is called the pole. The pole of the mirror. Okay. This is the back of the what? The curved mirror. So this will be the back. This will be the what? The front. Meaning that what? Reflection can only take place here. Okay. It cannot. This is the back of the mirror. Okay. Now let's go. So this is always called what? F. That is what the focus. This is always called focus. That is the what? The distance from here. Distance from what? From the pole down to what? To here. That so we can decide to what? To place our image here. Sorry, objects. Let's place our object here. Objects, and let's call this to what? To the HO. Let's call this to the HO. HO, that is what? The height of what? Height of the object. Okay? Height of the object. Height of the object. So let's call this to be A and B. That will be A, B. So this point is what we call B, while this point is A. Okay? And there's a rule that says that any ray that is parallel to the principal axis, a ray parallel to the principal axis, parallel, that is, look at it, parallel. This is the principal axis. The principal axis, you can see that the two rays are what? Parallel. So this ray is parallel to the principal axis. And what does the law say? It will what? It will pass through the what? The focal point. To pass through the focal point. So that will be the what? The reflection paths. Okay? Okay, passing through the focal point. At the same time, we must have minimum of what? Of two rays. Minimum of what? Of two rays. Okay? We have another ray also. Another ray coming from where? From this point what? Point A. From point A. Coming from point A. Coming from point A. Can see? Touching the what? The pole. Touching the what? The pole. And once there is a ray touching the pole, meaning that what? This mirror, the spherical mirror, will behave like a what? A plane mirror. A plane mirror, just as well as in a what? Plane mirror. Okay, this will serve as what? The normal. This will serve as the normal. This will serve as what? The normal. This will serve as the normal. Then it will be what? You know, reflected like this. Yes, yes. Okay, so where the two reflected rays, where they intersect, the point of their intersection, we have a what? Image will be formed there. Okay, image will be what? Formed what? There. So we can decide to draw the height of what? The image form. That is HI. Okay, so we can call this to be A dash B dash or A prime B prime. Okay, since this is what? An incident ray. Okay, this will be the angle of incident, which is theta. So reflecting like this, so this will be what? The angle of what? Reflection, that is theta equals to theta. So looking at this very well now, we have two what? Triangles. Okay, this triangle and this triangle. Okay, so we can call the distance from here, from the pole of the mirror down to what? To the object, to be what? To be u. Don't forget that we use u to denote the object distance. That will be the what? The distance of the what? The object directly from where? From the pole of the mirror. That's from the center. Okay. Also, the image distance. The image distance. This is the image form. So that is v. That's v. That's the image distance. That's v. Okay. From here, let's bring out the first triangle. We have this and this and this. So this is theta, this is P. Okay, this is A and this is B. So another one is this. The other one is this. I'll have it this way. This is P. Why this is A dash B what? B dash and what? Angle theta. Okay, similar triangle. So we can say what? A dash B dash, A dash, A dash, B dash over A dash, B dash over AB. Or you say perpendicular by perpendicular, perpendicular by perpendicular equals to what? So we have the distance from where? From P down to B to the what? To the U. Okay, why this is what is V. Okay, but don't forget that we have convention words towards this. And what are the conventions? Look at it. This is what? The ray of light, that is the incident ray. The incident ray. You can see moving towards the what? Moving that is parallel to what? To the principal axis. Parallel to the principal axis. Then we are having the what? The distance, that is the distance of the what? Of the image of the object. You can see the direction of the arrow opposing it in opposite direction, traveling in opposite direction to the incident ray, which means that this will be negative. Okay, this will be minus. Likewise, this also will be minus, because you can see the arrow traveling opposite to what? To the incident ray. This is all called the incident ray. Okay, so from there we can have A dash B dash over what? Over AB equals to B dash, that's B dash P over BP. Alright, A dash, or you say what? Jaw by jaw, base by base. Height by height, base by base. Height by height, base by what? Base. There are two similar what? Triangles. Okay, so what's A prime B prime? A prime B prime is what? It will be minus V. Minus V. Minus V. Why? Because you can see the distance of the image. The distance of the image form directly from where? From the pole. So opposing the what? The incident what? Incident ray. So that will be minus. That will be minus, opposing, not in the same direction, opposing. You can see the arrow, okay, over AB. AB is what? Is U. Everything equals to what? Equals to B prime, B dash B, B dash P, B dash P, sorry, ABP, that's this, that will be HI, this is HO, HO. Now, normally also, look at this, when you have what, if this is what, a principal axis, image, that is, upright image are always what? Positive, upright image, and why what? Erect image are always what? That is the image facing what? Downward, are always what? Negative, okay? So from here now you can see the direction. This is facing up, this is facing what? Down. So that will be minus HI over what? Over HO equals to B dash P, B dash P, that will be this, that will be minus V over what? Minus U. This and this will cancel, right? So that will be minus HI over HO equals to what? V over what? Over U. So we can have therefore HI over HO equals to minus V over what? Over U. Minus V over U. So therefore, we know that HI over HO is what? Is magnification. Therefore, we can have magnification to be equals to HI over HO equals to minus V over what? Over U. Which is, say the same thing as V equals to HI over HO proved. Proved. Where what? Where HI is the height of the image, HO is the height of the object. So that's what the negative sign, that's the negative sign, meaning that magnification is negative V over what? Over U. Over U. So let's look at what? The characteristics of the image form. Okay, characteristics of the image. So we're going to be looking at what? Magnification in what? In full, that is in details. Magnification in what? In details. Okay? So let's look at magnification in details. Magnification, that's number one. When you have magnification, magnification to be equal to what? Positive. When magnification is positive, that is HI over what? Over HO. That is HI over HO equals what? Positive. That is when HI, that is the height of the image and the height of the object are both positive. Then what will be the nature of the image? What will be the nature of the image form? Number one, that will be, look at this, this meaning that what? It will be in this form, that will be arrow or this also. Okay? When you have what? Magnification to be positive, that will be what? Meaning that what? The arrows will be what? Facing up. That is what? Upright. And what can we deduce from here? What can we deduce from here? We can deduce that image form will be what? Upright. Upright means what? The same direction. Upright, that is the same direction. Upright, that is the same direction. And what? And virtual. Because this will be what? Formed at the what? At the back of the mirror. When it's virtual, it means what? Image formed at the what? At the back of the what? At the back of the mirror. That is when magnification is positive, that is HIHO equals to what? Positive. That is same sign. Same what? Same sign. Same sign. Okay? Number two. When magnification equals to minus V, that is when magnification is negative. Negative, that is HI over HO is equals to minus this. That is same sign, negative. This and this negative, okay? That is facing what? Down, the two. So we can have this way. That is, this will be what? We can have same direction. That is, this will be what? Facing down. That is the object. The object will be like this, while the image will be what? Up. Okay? Number three, magnification magnitude. When the magnification magnitude is greater than 1. Greater than 1. That is, the magnification magnitude is what? Is greater than 1. Is greater than 1. What can we deduce from there? We can deduce that what? That the magnification of this, meaning that enlargement, enlarge image. What about this? This would be what? Real. This would be real and what? And inverted. Real and inverted. So that would be the what? The nature of the image here. Real and inverted. This would be what? Enlarge. That is, enlarged image would be what? Formed. Why? Because the magnitude of the magnification is greater than 1. The last one on the list, when the magnitude of magnification is less than 1, when the magnitude of the magnification is less than 1, this should be what? Diminished, and not point size. When you say point size, that is very, very small, not just very small. So it will be what? Diminished. That is when magnification is less than what? Less than 1. So I'll take this again. Positive, same direction. Why this is up and down. Okay? This will be the direction of the image. Okay? Real. It will be real. Real in the sense that is located at the what? At the front of the mirror. Inverted. That is upside what? Upside down. Okay? When the magnitude of the magnification is greater than 1, that is enlargement. That is enlarged image to be formed. Why this? When the magnitude is what? When the magnitude of what? The magnification is less than 1, this will be what? Will be diminished. Okay? Diminished. Okay, let's take a look at this. What about situation whereby we have magnification to be equals to minus half? What will be the nature of the image? What will be the nature of the image that will be formed? Due to what? Due to the negative value here. We can deduce that when it's negative, we'll be having what? Real image. Real what? Image. The image will be what? Real. Because negative, you can see, the magnification is negative. That means the image is what? Real. That's the first one. And what? And inverted. That is upside down. Inverted image will be formed. Real image will be formed. Okay? What about this half? That is 0.5. 0.5 is what? Is less than what? Is less than 1. Since 0.5 is less than 1, it means that the image will be what? Diminished, inverted, real. Okay? What about if you have magnification to be 2? That is plus 2. If our magnification is plus 2, what can we deduce from here? We can deduce that the magnification, the image form is upright, 1, visual, 2, and is what? Look at the magnitude. The magnitude of what? The magnitude of the magnification is greater than 1. Is greater than 1. What would that be? That is enlarged. Enlarged image will be what? Formed. Okay? So let's look at this question. Question 1. Q. Find the position. Find the position, comma. Find the position, comma. Size, and characteristics of image form by a concave mirror when an object formed by what? A concave mirror of focal length 10 10 centimeter. When an object of 2 centimeter high, when an object of 2 centimeter high is kept at A 15 centimeter, B 5 centimeter. Okay, look at the question. Find the position, size, and characteristics of image formed by a concave mirror of focal length 10 centimeter when an object of what? Of 2 centimeter high is kept at A 15 centimeter and B 5 centimeter. In order to solve this, you can see that this is not an OBJ question. This is a typical theory WAEC question. If you are very, very conversant with your past question. Now, what you need to do here, in order to get a full mark, please just interpret the question with the help of what? Diagram. Okay? We have this. Okay? Since we talk about what? A concave mirror. So now this will be the concave mirror. That's this point P. That's the pole of the mirror. Okay? We are told that what? It is 10 centimeter. The focal length. So we can call this part to be what? To be F. 10 centimeter. 10 centimeter. 10 centimeter. And we are told that what? The object is 2 centimeter high. Is kept at where? At 15 centimeter. Meaning what? 15 centimeter away from the pole. 15 centimeter away from the pole. So we can just mark this point to be what? 15 centimeter. 15 centimeter. So of what? 2 centimeter high. That's the height of what? Height of the object. Okay? So this is 15. So from here to here will be 15 centimeter. 15 centimeter from the pole. So what are we asked to find? I want to find the position and the size of what? Of the image. Where would the image be when you are having object placed behind F at a distance of 15 centimeter from the pole? If the focal length is 10 centimeter from the pole. Now recall that what? 1 over F is equals to 1 over V plus 1 over U. This is what we call mirror what? Formula. And what is 1 over F? So from here, we have to find the object. So we can make this the subject of the formula. That will be 1 over U equals to 1 over F minus 1 over what? 1 over V. So from there we can have what? We can have V minus what? V minus F over what? Over V times what? Over V times F. Image. Okay? This will be V. This will be U. Okay? This will be U. That will be U times this. So this will be U times F. Okay? So from here we can have what? U to be equals to what? U times F over what? Over U minus F. 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 Now look at it now. So from here now, we have to find U now. So U, that is what? The object what? The object, the image distance, V and U. This is V, the image, okay, U minus, okay? So we can say V equals to, so what's U? U is what? U, that is what? The object. This is the object. The distance of the object from the pole of the mirror, that is what? 15. But because this will be the one, the incident ray. Okay? The incident ray, you can see parallel to the what? To the principal axis. The distance of the what? Of the object is opposite the what? The direction of the what? The incident ray. Meaning that this will be minus what? Minus 15 centimeter times the focal length also. From here, that will be minus what? Minus 10 centimeter. Everything over what? What's U? U is minus 15 minus what? what? Minus 10. Okay, that will be minus times minus, that will give plus. So equals to minus times minus, that's plus, that will be 150. Everything over what? What will this be? Minus 5. Minus 5. So this will give us what? Minus 30 centimeter. So that will be the what? The image. That will be the image distance. The image distance is minus 30 centimeter because it's opposing the what? The direction of what? Of the incident ray, which we can locate this here that what? The image will be somewhere around there. Okay? The image will be somewhere around there. So it can be deduced that since this is negative, is opposing the direction of what? The incident ray. So therefore we can say V is equals to what? 30 centimeter. Then what will be the what? That will be the position. So the image must be placed at what? At 30 centimeter behind the wall, that is above what? At the back of what? F. So what will be that will be the position? What will be the one? The size. What will be the size? We know that magnification is equals to HI over what? HO, which is equals to minus V over what? Over U. Isn't it? So implies that magnification, what is HI? HI is not given, but what is minus V? That will be minus into bracket, minus V, that's minus 30. V is minus 30 over, don't pick plus, okay? Because it's opposing the one, the incident ray over U. What's the value of U? U is minus 15, okay? Minus and minus will go, that becomes what? Minus what? Minus 2. Meaning that what? The magnification is minus 2. So since the magnification is minus 2, what can we say now? That is be the what? The magnification. So from there we can deduce that the height, the size should be, okay, this will be the size, magnification. Then what will be the what? The characteristics. What will be the characteristics of the image? Since it's negative, then we should know that what? Is inverted. Is inverted. Since it's minus, is inverted. Remember from the rules of image form, that is the characteristics of what? Of image form, okay? Using what? Magnification. Since it's negative, the image form will be what? Inverted. Number 2, it will be what? It will be real in a sense that the image is located where? At the front of the what? At the front of the curved mirror. Number 3, what can we deduce from there again? What is magnitude? Magnitude of 2. That's the magnitude of the magnification is what? Is greater than 1. Since it's greater than 1, we'll be having what? Enlarge what? Enlarge image. You can as well what? Try this. Okay? Try this. Thank you and God bless you.